Welcome to week 10, lecture 46. So, today we will start our discussion on level measurements. Similar to temperature, pressure, flow measurements, measurement of levels is also an important activity in any chemical process industries. Industries are required to store several liquids in large containers. They are required to store several liquids such as various solvents, fuels, waters, other utility liquids, etc. So, it is required that industries keep a track of how much liquid or how much solvents, waters, etc. is there in the large containers at any given point of time, so that replacement can be done whenever it is required. Although normally by level measurement we talk about measurement of liquid level, measurement of solid level is also important in certain industries, particularly measurement of level of powders, granular solids, etc. So, today we will start our discussion on liquid level measurements. So, today what we will do is we first classify various level measuring instruments that are available. Some of these instruments can also measure level of solids or granular solids, and then we will talk about some level measuring instruments that we call direct liquid level measuring instruments. So, wide variety of instruments are available for measuring the level of liquids. Some of these can also be used to measure the levels of solids that are in the form of powders or small particles, meaning granular solids. A wide variety of physical principles are used to measure levels. So, if you have various instruments will be based on different principles. So, wide variety of physical principles are used to measure liquid levels. Common types include sight, pressure, electric, sonic and radiation. For example, we will see later that the instrument based on radiation principle can be used for measurement of liquid level as well as solid level. So, sight, pressure, electric, sonic and radiation, these are the various physical principles that are used to measure liquid level, and some of these can also be used to measure solid level. In some applications, only a rough indication of level is needed, and simple devices such as dipsticks or float systems are adequate. However, in other cases where high accuracy is required, other types of instruments must be used. Liquid level may be expressed in terms of the pressure of column that it exerts over a datum level or the length of the liquid column. So, a liquid level can be expressed either in terms of the pressure the column exerts over a datum level, that means in terms of head, or the length of the liquid column. So, this is one possible classification of level measuring instruments. Broadly, we classify them into two categories: direct measurement of liquid level, indirect measurement of liquid level. So, under direct measurement of liquid level, we have dipsticks, hook type, sight glass, float type level measuring gauge, displacer type level measuring gauge. So, dipstick, hook type, sight glass, float type and displacer type all fall under the category of direct level measuring instruments. Indirect measurement of liquid levels, here we do not measure the liquid level directly, but we measure something else and infer the value of liquid level from that. For example, if we consider a liquid content in a tank, let us say open tank, of known dimensions, and if I measure the pressure at the bottom of the tank using a pressure measuring instrument, I know that this pressure P equal to density of the liquid times acceleration due to gravity times the length of the liquid in the tank. So, P equal to rho g H is the familiar equation. So, if I measure pressure, I know the density of the liquid, then I can calculate easily the level of the liquid in the tank, that is H. So, I measure some property related to the pressure and then infer the value of the level from this information. So, under indirect measurement of liquid levels, we will have hydrostatic pressure type, bubbler or purge type, capacitance type, ultrasonic type, radiation type. So, let us start with direct measurement of liquid level. We will start with dipsticks. Dipsticks offer a simple and inexpensive means of measuring level approximately. It can measure liquid level only approximately. Dipstick consists of a metal bar on which a scale is etched. The bar is fixed at a known position in the liquid containing vessel. A level measurement is made by removing the instrument from the vessel and reading off how far up the scale the liquid has weighted. So, this is an extremely simple way of measurement of liquid level. It is something like putting a scale in a container which contains the liquid level, and we see that how far the scale is weighted by the liquid. As a human operator is required to remove and read the dipstick, this method can only be used in relatively small and shallow vessels. So, an ordinary dipstick is shown here. It is a simple graduated rod that can be dipped directly in an open tank to read the depth of liquid. You can see the graduations on the dipstick. This is how oil level is normally measured in car engine. A dipstick cannot be used for tall vessels or high pressure tanks, because high pressure tanks must be closed tanks. Dipsticks gives visual indication of level only. It is economical but has low accuracy. It is not possible to have continuous online measurement using such a simple method of measurement. But where only a rough indication of the liquid level is necessary, this will give you an approximate indication of the liquid level in the tank or the container. This is a slightly improved version of dipsticks. We call it optical dipsticks. So, what is done is as follows. You have a light source here. So, we send a beam of light which gets reflected by this mirror, then it goes down, passes round the chamfered end. This is the chamfered end, passes round the chamfered end of the dipstick, and the beam returns, again gets reflected by another mirror and enters the light detector. So, if the liquid level is below the optical dipstick, Due to total internal reflection, the light from a source is reflected from a mirror, passes round the chamfered end of the dipstick and enters a light detector after reflection by second mirror. Now, if the liquid level is say here, then what happens is liquid level now will not reach, the light will not now reach the detector. When the chamfered end comes into contact with liquid, its internal reflection properties are changed and light is transmitted into the fluid and no longer enters the detector. So, if the liquid level is below the chamfered end of the dipstick, the light detector will receive the light. When the liquid level is above the chamfered end or when the dipstick is in contact with the liquid level, then the liquid will be transmitted into the fluid and the detector will not get the light. So, if I can bring this dipstick or if I can move this dipstick up and down, it should be possible for me to find out the level of the liquid by noting when the detector does not receive light. So, by using a suitable mechanical drive system to move the instrument up and down and measure its position, the liquid level can be monitored. The optical dipstick allows a reading to be obtained without removing the dipstick from the vessel. Therefore, it is applicable to larger and deeper tanks. Unlike ordinary dipsticks, it is not necessary that we have to remove the dipstick from the tank. But of course, there should be a mechanical drive system to move the instrument up and down, so that the chamfered end of the optical dipstick comes in contact with the top surface of the liquid level and the light transmits into the fluid and does not come back to the detector. Next, we talk about hook type level measuring instrument. So, this is another very simple way of measuring liquid level. When the level of liquid in an open tank is measured directly on a scale, the scale may be in the liquid or outside it, it is sometimes difficult to read the level accurately because of parallax error. In this case, a hook type of level indicator is used. What you see is a hook type of liquid level measuring instrument. So, this is the hook, and here you have scale. The hook is pushed below the surface of the liquid. It is then gradually raised until the point is just about to break through the surface. The hook is then clamped and the level is read on the scale. Next, we will talk about sight glass or gauge glass as level measuring instruments. We are talking about direct measurement of liquid level. Sight glass or gauge glass is another very simple level measuring instruments. It can be used to measure level of open tank as well as closed tank. So, sight glass or gauge glass is nothing but a transparent toughened glass tube inserted into the side of the tank or vessel containing the liquid, and there is a calibrated scale etched on the toughened glass tube, which is the sight glass. So, this is the sight glass. So, sight glass or gauge glass is a transparent toughened glass tube inserted into the side of the tank or vessel containing the liquid together with a calibrated scale. Diameter of this sight glass tube should not be too large or too small. If it is too small, there can be capillary effect. Liquids will keep level. So, the liquid level in the tank as well as in the sight glass will be same, and we can get the visual indication of the level in the tank or the vessel. So, sight glass offers simple, inexpensive and direct measurement for clean or colored liquid. Since we are inserting this sight glass to the tank, this may weaken the side of the tank. Also, the transparent glass is liable to be broken or damaged. Usually, the sight glass gauges are installed with manual shut-off valves at both ends. So, you have a shut-off valve, you have another shut-off valve. This is useful as you can isolate the gauge easily during maintenance or failure or when replacement is necessary. Usually, ball check valves are used as the shut-off valves. Next, we talk about level measurement by float. There are various different designs available which makes use of float for indication of liquid level in a tank or in a large tall vessel. The design that is shown here is for open tank. A flexible chain or tape passes over a drum type pulley, holds the float on one end and a counterweight on the other end. So, we have a float that I have put on the surface of the liquid level in the tank, and there is a counterweight, and this float and counterweight are connected by a flexible chain or tape, and this chain or tape passes over these pulleys. So, a flexible chain or tape passes over a drum type pulley, and this flexible chain or tape holds the float on one side and a counterweight on the other end. Density of float material is less than the density of the liquid. So, the float will always be on the surface of the liquid. So, as the liquid level changes, the float rides the surface level. So, as the liquid level goes down, the float also comes down with the surface of the liquid level. As the liquid level goes up, float also goes up with the surface level increasing. So, float rides the surface level to provide the measurement. So, as the float goes up, the counterweight will come down. As the float comes down, the counterweight will go up. So, if I attach a scale here, the position of the counterweight against the scale will tell me the position of the float inside the tank, and the position of the float is nothing but the measure of or indication of liquid level. So, this scale can be calibrated directly in terms of liquid level in the tank. So, from the position of the counterweight against the scale, I can know the position of the float inside the tank, and the position of the float will tell me the level of the liquid inside the tank. As the float goes up, the level of the liquid inside the tank is more. As the float comes down, the level of the liquid inside the tank is less. The typical range is around 15 centimeter to 20 meter. If you visit a chemical process industry, most likely you will see this float chain type liquid level measurement as attached to very tall, large storage tanks. So, typical range is up to 20 meter. The float is usually made of copper with nickel painting to avoid rusting. Note that gauge is almost independent of liquid density. As we mentioned that there are various designs available. So, this is another variation. So, here this is the float, which is usually a spherical ball. This is the weight, float and ball, float and the weight or the counterweight is connected by this flexible tape or chain. This passes through this pulley, and here I have a pointer. Here I have attached a pointer which moves against this scale as the float goes up or comes down. Standard floats are spherical or cylindrical. We should use bigger diameter float for low density liquid and vice versa. So, use bigger diameter float for low density, use smaller diameter float for high density liquid. Typically, a spherical float will have diameter in the range of 75 millimeter to 175 millimeter. Another variation of float type liquid level measurement, what you see is known as angular arm float type liquid level measuring instrument. So, a ball float is attached to an arm. The angle of the arm is measured to indicate the level of the material. So, you have the liquid in this tank, and I have a float, and this angle will change with change in the liquid level. So, if I can measure this angle using an angle sensor, I can take that as an indication of the liquid level. The monitoring of the fuel level in the tank of an automobile uses this principle. it is possible to have a float type liquid level measuring transducer, a float type liquid level transducer. As of now, what we have seen is float chain type instrument, where you use a chain to connect the float and a counterweight. And now I read the position of the float either by looking at the position of the counterweight against a scale, or it is also possible to actuate the movement of a pointer against the scale as the pulley brings this float up or the float goes down with the change in the liquid level. Now, it is also possible to track the movement of the float by an electromechanical sensor such as LVDT or with help of a potentiometer. So, what we will do is, as the figure shows, this is the float. We have a pivot here and this is an arm in this potentiometer. So, movement of the float can be tracked by attaching a potentiometer or LVDT to it. Next, we talk about float and shaft type liquid level measurement. Float and shaft type liquid level measurement is usually meant for closed pressure vessel, but it can also be adapted for open vessel. I have this float which is often a spherical ball float. Then this connecting arm is attached to this float at one end and this connecting arm is attached to the rotary shaft at the other end. This rotary shaft passes through the wall of the tank through a stuffing box, and the other end of this rotary shaft is connected to a pointer which will travel over a circular scale. So, as the float changes its position, the rotary shaft will cause the pointer to travel against the circular scale. So, float is connected to the connecting arm and the connecting arm is connected to the rotary shaft which passes through the vessel wall through a stuffing box. A pointer is attached to the rotary shaft. Thus, as the float changes its position with change in liquid level, the pointer travels against a circular scale and the circular scale can be directly calibrated in terms of level units. Note that with help of this stuffing box, it is possible for me to take the shaft outside the tank. For a spherical float, highest sensitivity is obtained when float is half immersed. So, we will stop our discussion today here.